Alright folks, konnichiwa. This is me switching back to my MacBook because I want reliable Rust compilation here, and I'm going to continue. I'm not fully sure if okay, the stream is live, that's good. I'm going to close that. I'm going to play some music. I'm going to verify on my other device if the stream is actually live. Okay. I'm going to verify on my other device if it's actually live. Mute my mic first. Alright, sorry. Yeah, so since my gain is at max right now and I have music running at a reasonable volume, I just wanted to be sure things are fine, and I think it is fine, so I'm going to continue. Cool. So I'm going to go to Philops Rust blog and jump to the VGA mode. This is what I want, and I already have this from last time. I just did a git pull and compiled. I think cargo C itself should be fine. Okay, I need the Rust up nightly, dude. Nightly, how do you get nightly? Just a context. So basically, if you don't remember, or if you're looking at this video for the first time, or if this is part of some clip, we have a freestanding Rust binary here, which is basically this main RS. So instead of an fn main here, if you see, we have a C compatible start function with a no mangle unsafe, no mangle and unsafe on it. No mangle basically makes sure that this start name is preserved in the elf binary, so it runs, right? And unsafe is because we are doing some unsafe block, unsafe stuff here, right? So what we are doing here is basically writing hello world to the screen, but since this is real programming and not just not just a printf, we are basically using VGA, which is this 25 column, I think 25 row something. We'll read up on that again. It's a memory array, it's a memory area. So when we write bytes to that, it actually displays something on the screen. So this is a actual program that can boot directly without an operating system. In order to make sure we are able to compile it directly, we have to do a couple of things. I have entire videos on that, and I'm basically following this guy's blog, Phil blog, so you can just look at that guy. So that's totally okay. Yeah, so first of all, I have this profile panic abort. I think this can be removed. It's not very crucial, but yeah, the main thing is, if you look again at my main function, I have this no standard and no main. No standard means there's no standard library included, so there's no OS wrappers in our code, in our binary, and no main basically makes sure that the underscore start is not auto injected by the runtime, and it also tells the compiler that we won't have the C runtime and CRT and those things available. Cool, conf rs and all is fine. Another thing is, we have this custom cargo config where we are using a custom target, right? Which is our own custom target right here, which is this JSON. So instead of, for example, this particular machine would be AR64 Apple Darwin. My other laptop is x64 unknown Linux. So this is x64 unknown none. So we're going to run it in a VM. So it doesn't matter that I'm developing on Mac. We should be able to boot the x86 64 thing in Chemo. So that's great. I think while we are at it, I'm going to quickly go and detach this, open a new one, just do a Chemo. Right, I don't want to wait and then install later. We need Chemo for booting the VM. We could use any VM, but Chemo is like it's good, right? So I'm just gonna let that run and switch back to our it's another project there. Learn. Okay, this is not learn, it's heyos. It's heyos. Okay, I'm gonna make the font a little bigger, especially over here, so we are able to see stuff. So yeah, so LLVM target is this thing, unknown none. There's no vendor and there's no target operating system. It's just the x86 part that fixed. Data layout is something that LLVM takes as an argument, which decides the various size of, okay, how much is an i64, how much is an i28, with the types and those things. These are standard stuff, target ND, and this is fine. Custom linker arguments and all is fine. Panic strategy abort. I think this should be enough. We should be able to remove the abort from our cargo terminal, but we'll get back to that later. And we have all this stuff, right? So right now by default, if I try to do a compilation, it fails because using a custom JSON, I have to pass this flag, but I don't like passing flags. I'm going to switch to nightly. So I think I just have to first install nightly and then I think enable it. Rust of default nightly, yeah. So I'll set the default Rust toolchain to nightly, which lets us do stuff like custom JSON. So now if I do a cargo C, I should be able to compile it. Alright, so another thing is we are trying to wait. Okay, some actual specific stuff. We need nightly on this guy. Cool, so we're able to compile stuff. It's getting our dependencies. By the way, if you see here, it also got compiler built-ins, the Rust core, and other dependencies that I have. But yeah, okay. Now this is the error I was facing in my previous attempt at this stream. I don't know, this was not there in the last episode 3 video that I did. So let's debug what it is. The blog does not have any information on what this is. So let's figure out where it's coming from. I got this on both my Linux compiler as well as on this Mac. So I think it's nothing to do with the target operating system. Let's jump all the way up. 4,000 lines, are you kidding me? I'd have to scroll with the mouse. Yeah, there's a use case for everything. What is this? Where is it coming from? Something to do with the result. I mean, I did add the settings aspect to my crate, right? I did add this, sorry. I did add, what is going on? What? I don't know, some case was weird. I did add this, and okay, proc macro error is a weird compiler. Rust analyzer thing that happens sometimes. What's your problem? Thank you. So I did add this, and I'm using like a result type here. So maybe that's what's causing it. I don't know. I'll do one thing. Let me comment this guy completely. Dude, doing stuff without looking at your keyboard is sometimes a little harder. Nope, that is not it. What is happening? I could ask an AI easily. Okay. Wait. Did I close the stupid thing? Okay, good thing Chemo is installed. Now that go to say OS. Okay. I don't know where the box type is coming from. I'm not doing any box type myself. I think I kind of have got an idea where this is coming from. Yeah, it's not coming from convirus, undo that. It's coming from the VGA. So VGA module is what I added, and in the spec I have these. And in the example in the blog, these had additional stuff derived on it, partial egg, and I think those are the ones for now. So I'm gonna add those. Would I have to ask AI? I hate what are you trying to do, Codex? Just open to this straight away. Okay, what's broken in the compile? I don't know, I've been facing this since recently. I'm not exactly sure what's happening yet. It ran straight away on. I just looked at git status. do that. How do you have like 500 errors? It's coming from Surday. Why is it doing standard? Okay, let's do one thing, dude. I'm gonna do one thing. This is not it. I'm gonna go here. I'm gonna just remove the font. I can always add it back. I'm gonna just remove it. Okay. I'm gonna go to cargo terminal. I'm gonna just remove Surday. Not why? Shutting down as if it's an entire computer. Why is Codex so slow? I don't like Codex, dude. Nope. Alright, I'm just gonna remove dependencies. Let's see. Oh yeah, I think that's it. Anyhow, also. You know what? I think it came mainly from anyhow. Okay, I want to do like see, I want to be able to use like Surday and also. Anyhow, I don't really need. What happened? No. Just anyhow. It's switching from Mac to Linux. Command and control is a forever struggle, and I need to fix it, dude. I need to make my non-Mac setup use command, because that's the only realistic way. Because at work I have to be on Mac. Yeah. Surday breaks as well. Okay, so I can't use Surday. What kind of what can I build in Rust without Surday, dude? Dude, I removed it. Okay, maybe it's not Surday. Yeah, it's configuring. No. Okay, but we do need Surday, dude. We're not doing deserialize. Okay, I just added it like by habit. Okay, so I think get boot image first. Is it just boot image? Yeah. Alright, go to already removed conf. This is fine. Okay, so cargo boot image. We're compiling the kernel. It prepends the bootloader to it, so the mbr BIOS boot should work. We have an error. Yeah, I need this LLVM tools preview. The same thing happened on Linux as well. Just that was a lot faster. We already have chemo, so that's great. Alright, this is working. I'm going to go to my blog and try to figure out in the previous chapter what was the command to start the VM in chemo. Chemo system drive format raw file. Okay, I think in my case it will just be chemo drive. Let's see. Chemo not found. System ZSHRC. Alright. Now tell me, dude, what is the problem? Which chemo? Chemo not found. Is that it? This is actually a command. Alright. Okay, drive format, what is it? You're doing DD and all, dude, for a real machine bootable drive. Are you kidding me? Alright. You know, those things just make me happy. Format raw and then file. something. I need to get the target boot image. No. Target a debug build. Nope. Do cargo boot image release. Wait, the path was right here, dude. Okay, fine. It was right here. What am I doing, dude? Copying with the mouse. Are you kidding me? All right. Oh wait, it is running. Yeah, but it's not. It's running behind this thing, dude. Are you kidding me? I don't like that. Okay, do one thing. What is this? Sorry. Dude, just jumping between Mac and... How do I make something? Floating mode. Floating. Come on. Float. Windows shadow. It's not this escape. Space. Second. Nope. I thought my keyboard is set on a weird thing that... Command Shift? Doesn't make it floating, dude. Why did the browser open? It's just so janky, dude. I really want Asahi to work on this beautiful laptop, dude. Yeah, it's right behind that, dude. I hate it. Are you telling me this is gonna be the reason I won't be able to do this? This is just a Arch user stuck in macOS problems, dude. The only way I can think is max out the transparency in Ghosty so that I can see it, but then that's not right. That's such a compromise. Okay, it is booting, dude. It's right here. I can see it. Here. It's so tiny though. Okay, maybe if I go to the Mac terminal and go to heyos. Okay, okay, I think I got my solution. I just need to have the Mac terminal open, have it be at the bottom. I'm not on a Arch again. Thank you. Make it as tiny as possible. It's out of my way. Go to heyos and do this. Thank you. Command Shift C apparently. Control Shift. I don't know how to really do. Are you kidding me? I'm stuck in the VM. Control Shift, Control Option G. Okay, thank you. Yeah, so this is our VM and it has our hello, well, hey, welcome. It was not prettier. Are you sure you want to quit chemo? Quit chemo. Perfect. Okay. I finally have this command right here. I'm gonna make it as small as possible. Okay, I don't think it can get any smaller than that. Alright, cool. So we are good to go. Now the next task is we need to get the VGA text mod running, because it's not realistic to just go and write bytes every single time. So I need an interface to do that. So the blog explains what VGA is, how it works, and then it also takes us through, you know, setting up a writer that can write stuff. So in the end, you can actually do print line, right? So that's the goal. Okay, so we're gonna start with what they have, and then maybe add stuff to it, like colors and all that, right? Probably. I want like a blinker. That'll be really cool. Yeah, all right, so we have this thing. It's intensity RGB, IRGB, which is the VGA standard. We already talked about this before, so I'm not going to jump too much into it, and I already have that enum right here. I'm going to make this guy a little smaller. Actually, I'm going to quit this because I like my things to be on the I have no idea why heyos. Oh, it has HE in there. Alright, thank you. Cool. Thank you. Get bigger. Alright. Cool, so we have the stuff, we have the stuff. Cool, now let's set up the VGA thing. First of all, in the spec, I have my color, which is RGB. We know how this works. I'm not jumping into it again and again and again. But again, just in case I'm making a clip, the way this works is we have intensity RGB. So for example, 0 and then 100 would be red. 0100 is basically to the power, it's 8. I'm guessing. No, wait, sorry. It's 012, right? So 2 to the power 2, which is 4. So red is 4, right? If you want something like, say, a light blue, let's say, so that would be 1 RGB. So 1001. 1001 is 1 plus 8, 9. Perfect. That's how it works. We can read up on this, but I know how it works. I have this guy, which is great. Then I have this color code, which is a U8, and we have wrapper transparent on it in order to have it use the same memory layout as the member type. Again, I went through this before. I want to get into this stuff, right? So let's follow the blog. Cool. So I have the colors. This is fine. We went through this stuff before. I haven't added these two right now because I'm going to add the traits when I need them. That's how I prefer to write. Cool. So we have color code. This is just the same exact code as what we have there. So in VGA, the color code, the coordinate, if I may, has like 8 bits. Okay. So it's like the first 4 bits are for the byte itself, the character itself, right? One character is 1 byte, so I think it's 16 bits. Sorry, yeah. So it's the 8 bits are for character itself, and then we have 8 bits for the color, where there's foreground and background. So we have the divided by into nibbles, 4-bit nibbles. So that's how it is. So that's why we need to do this, where the color takes foreground, background, and then combines them. By combines, it just means puts them together, right? So we have to do left shift 4. So shift it by 4 and then add that. That's how it works, right? Cool. That's cool. So fine. So now we need a text buffer. So I think I've already done up to here. I have this character. Yeah, I didn't want to call it screen care, so I just called it character. Fine, whatever. Doesn't matter. For a character, what do we do? Yeah, ASCII character color code. This is straightforward. Okay, the buffer is where I was stuck and I didn't implement that. So let's do that now. All right. So since the field, oh, 1 second, I was making coffee. Alright, I have some caffeine and a glass. Not a glass, a mug. Let me pour some in. The techs are going crazy. But not now. I'm gonna check them out after this stream. Alright. Cool. So as we talked about, our buffer's height is 25 rows and 80 columns. So we have that. So this is where I wanted to get the settings in, and I think I did that last time when I broke some stuff. So I'm going to do one thing. I'm going to have in VGA itself, in mod maybe, I'm just going to keep this in mod. Alright. Buffer height and width are there, and then buffer. What is this syntax? It's a 2D array where we have the screen character, the buffer width, buffer height. So we start at the beginning, right? So the first character we put at, instead of 0 0, we are putting it at buffer width and buffer height, which would be like the bottom right corner, I'm guessing. Cool. So this is fine. This makes sense. I don't have any working, but I'm not setting that up again. It's possible to set up anything. Alright, cool. So I have this guy. Sorry dude, my caps lock is on, okay. Okay, so within spec, I think just spec was, don't worry about refactoring yet too. Fine, let's just go like this. Cool, so I have a struct a buffer. So this also has to go with the same memory layouts. I think the wrapper for this is going to be transparent. Yeah, that makes sense. Right, so I have this guy, and it generally, yeah, it has characters. Okay, which is a 2D array. Okay, so I'm going to start with a character, comma, I need these guys. Okay, so buffer width, why is it not auto completing for me? Charts, too much with that still. Helmet. It's just a types, right? Yeah. Why? Why do you have to type that? This is the issue. Alright, so I have buffer defined. Of course everything is dead code right now, so it's not being used. Alright, and now for the buffer we can have the, okay, now we have the stuff. Now let's go for writer. Okay, it actually, this part is right. I'm gonna make this buffer.rs. Okay, I'm gonna rename this guy to color because all it has. It just has the color stuff. It also has a character though. Okay, dude. Sorry. You can be spec. What? The file is renamed to a VR. No, you don't do that. You do this. This is called spec only. Characters and colors. It is spec. Cool. So I have this guy. I have the colors, and I have a buffer, which basically has this thing, and I need the use color super dot spec dot character I'm just gonna replace. Okay, it is a public one. What's the issue? Module is not public. Alright, cool. So I have the buffer now. This makes sense, right? It's basically the type character for each placement, and the height is the height and the width is the width, right? So that's how that goes. That's the buffer. Now we have that defined, so we can now do the writing, right? So okay, since field ordering in default structs is undefined in Rust, we have to do repc, which is on the screen cap. Okay, because we do want them to be ordered in memory in the same way as it's stored. Okay. Buffer, it makes sense, right? We want the same memory layout as a single field, so that's why we use repo transparent. All right. To actually write to screen, we now create a writer type, color code, column position, and buffer. Makes sense. So we are basically mutating this buffer as we go, and the column position is something that we initiate with probably a default, and then as we write, we increment the column position. That's my idea, right? I'm pretty sure that's what's happening. Yeah. Right. We do the memory writing like this. We keep updating the buffer. That's it, right? Okay. I'm curious how the buffer maps to the actual XB8000 memory area. We'll figure that out later, right? That's fine. Yeah, and if it's a new line, we call new line, and new line is something we have to implement later. This I am okay with. So let's do that. I'm thinking I'll put the writer in the buffer itself, or I'll put I'll make this writer. No, you don't rename the file. That's not how it works. You rename the module. Okay. What is wrong with Rust Analyzer? You can't do a simple refactor to it. Okay. Go to writer, and this guy can move back to spec. We already have it here as well. Alright. Cool. So it doesn't have anything else now. Let's start. So we need a struct called writer. Okay. We need column position. It's gonna be a U8. U size. What is the thing again? New code should use the associated constant directly in a primitive type. Okay. Oops, sorry. Yeah, color code, and we have the buffer, which is gonna be my guess is static mutable reference to buffer. That's my guess, because it's a mutable reference and we want the reference lifetime to be valid for the entire run of the program. That's my guess. That's what it is. Perfect. Alright, yeah, exactly, right? We have an explicit lifetime saying that this should be valid for the whole program to run. It's considered cheating in the general sense, but this is actually a valid use case for tick static. Okay, cool. So let's have a write thing now. Impl writer, pubfn write self, needs self, and it mutates the buffer, so it needs to be a mutable reference. Makes sense. What else? Yeah, what byte are we writing? Oh, we don't need to get this thing. We'll see. Okay. Any returns? Result? Nothing. Okay. Unit. Okay. So first of all, if it's a iflet why do you need iflet? If it's a direct match, dude. Match byte. If it's a new line character, then you do something, right? I think let's just do that. Fn new line. I'm not even sure what that's gonna do. I just call self dot new line, because when we do a new line, generally what happens is we move to a new line, but here that would basically mean that we have to move to the next row in our 25 row this thing, right? So that's why we have to go new line. This guy has to take, again it's going to be mutable reference only, new line. All right, and other cases I'm going to thing. So what are we going to do? Let's look at it. Let's not look at, let's read what's happening. Okay, if it's new line, then we don't do anything, we just call this an implementator. Fine, other bytes are printed in the second case. All right, when printing a byte, the writer checks if the current line is full. That's the first check. Okay, in that case a new line call is used to wrap lines, which is what's happening here. So if the column position is greater than or equal to buffer width, we call new line. Makes sense? If it's full, we have to jump to the new line. That's the first thing we do. That makes sense. All right, then it writes a new screen character to the buffer at the current position. So we basically, current position in the buffer is row column. Row would be buffer height -1. Why is it -1? Because we are starting from 0. Makes sense. Call is a column position. Okay. Okay, I'm now going to do this. Wait, why are we always starting from buffer? Are we changing the buffer height now? The row updates in the new line implementation is what I'm thinking. So don't we need that as well in the as part of the struct? So right now what they're doing is row is always buffer height -1. It's always the first one. But what if the column has shifted? Oh, we are got it. So we are just overriding the same line right now. Okay. Okay, again, let me make sure I'm live. Okay, again, let me make sure I'm live. Okay. What about the music? Yeah, it's fine. Alright, so I need another sip of coffee. This is very straightforward, the rest of it. The only thing not clear is, okay, why is a color code also like a self-taught thing? Because the new writer is in a particular color. Why can't you have mixed colors? Okay, I'm already thinking of the possibilities, but this is reasonable, I think. Yeah, that makes sense. I create a writer for yellow and we write in yellow, that's fine. Only thing that's like biting me right now is this. Why are we doing this? Why not take the row as input? We want to write at the bottom right now. That's why we are doing this. Fine. Let's move with it. Okay, let's go. So why are we? Okay. B. What's the problem? This is B. Single quotes. Yeah. All right. So in this case, what I have to do now is the first thing: if our set.column position is greater than or equal to buffer width, I need the buffer width. Are you kidding me? Why can't that? I don't want this to be a constant. This is a pre-allocation thing, dude. Like, I could have done a vec here and taken the height and width as input and allocated accordingly. But then the type here would be confusing. Fine. I just made a pub constant, it's fine. So I'm just gonna go EGA spec buffer width. So if that is greater, then I just do self.newLine. Alright. The next thing I do is write the byte. That's it. Let's write the byte first. No, I need the row and column, right? So the row, we are taking the last row, which is, oh what? I don't like doing this. Okay. Okay, this is spec dot buffer height -1, which is basically last row. Okay, and call is current position, and all I have to do is set dot buffer of row comma column call equal to the byte, no, not the byte, screen char spec character is public. All right, character new has, okay, bytes, I'm guessing, yeah, okay. So the B and code, which is the color code. Why would you forget the semicolon? Are you kidding me? I'm coming from gold. Okay. What color are we choosing here? As part of the writer, so set dot color code. Alright, so I do that. Of course I have to do a let. I'm surprised I didn't do a colon equal to here. Okay, so row is u size and buffer expects, I think, u8. I have to do this as u8. No? Okay. What is it? Cannot index into. Isn't that what you're doing here? You are doing here. Dot chars apparently. Oh yeah, the buffer has chars, right? Show me that. Oh yeah, this thing is called chars, right? I like it. Characters. Layout. Chars it is. It's okay. It's okay. I was thinking a few things, but I don't want to go with those things right now. Yeah, buffer is a reference. You can't if you do chars, and the reason you can't do that right now is because this has to be pub. Function coloring is just painful, dude. Okay, color code. Let me figure out what's happening. Let me go to the writer. Okay, color code is a mutable reference body. Mutex what? Color code. No, that's a problem. Color code can't be a reference. Okay, so one of those things. Did they clone? They did not clone. Why didn't they have to clone? What is spec? I think I need coffee. Go back. I shouldn't need a clone now. Yeah, perfect. Because it's just a simple struct that is basically just a few u8 stuff. So it's just, yeah, it's just u8. So there's no harm, and it can just have a copy. All right. So I have this stuff which matches this, and we're good. Aha, of course, once we are done writing, we have to change the column position to 1 by 1, right? So that's clear to me. Alright, that's fine. We have the writer now. Okay, To print the whole strings. To print whole strings, to convert them into bytes and print them one by one. Okay. We're appending a new line. I like that. I mean, okay. Print line then. Fine. What is this? Only supports ASCII and the additional bytes over here. Rust strings are UTF-8 by default, so they might contain bytes that are not supported. Or that's what this range is. Okay, what is this character? FE. What is that? I think it's a fixed color, fixed byte. It's a square bracket or something probably. Okay, that makes sense. This is not write string to me. It's print line. Right? Alright. So pub fn print line. What's up with you? Actually, yeah. Right line. Okay, that makes a little sense to me. Okay, we of course need the mutable self-reference here, and we need bytes. No. We take a string. All right, and then for b in s. Okay, I think if you do bytes, I need to get bytes directly. Alright, that's what they did. Alright, so if it's in that, I'm just gonna copy that bit. So 20 to 7e. We have a new line being added in the beginning itself. Why is that? Okay, this part I'm not clear on. Why are we piping the new line in the med check? Oh, because whatever we do here is what we no, we're just passing on byte. Why are we doing this? Why are we doing the pipe new line on match arm when we pass byte in? Oh, it's an OR. Ah! It's not, it's just an OR. Okay, new line is not in this range. No, I'm not gonna do that stupid unreadable crap. Just give me this range. Okay, if it's this range, one sec. Match B. Okay, if this is the case, I'm gonna do self dot write by write byte. Okay, if it is new line, I'm going to self dot write b. Else I'm going to do self dot write xfe. Zero xfe. That's so much more simpler. Alright, I have this guy now. That's good. Cool. So now that this part is clear. Oh, it's a tilde character. This is a tilde character, right? Oh no, this is the tilde. This is the thing we are printing. The unprintable stuff. Okay, new line or anything between space and tilde. That is what this range is. I want that. It's ASCII basically. ASCII and space, anything within space and tilde. Okay. Alright. Which is still ASCII, right? That is what ASCII is, not AND. It's just ASCII, dude. Alright. Cool. Don't go defining ASCII in a comment. Alright. So this is fine. Try it out. So you create a writer and you write bytes and you write strings. Okay, so you have write bytes and write strings. Yeah, fine. Yeah, I think this is more of write string. We're not doing the new line thing that I thought. So it's just yeah, this is right. This is right. This is right. Sorry. I always do this way. Sorry. Alright, thank you. Okay, but how is it gonna work without doing the x1000 thing, dude? Where did I do that? What is this? What is this thing? In the okay, we're passing it right here. So if we do this thing as mute buffer, when we cast it as a buffer directly, yeah, it's weird, dude. We take an integer as a mutable raw pointer. This has to be unsafe because we are doing mutable reference shit. That's okay to me. But yeah, this is a strange one. It first creates a new writer. That's okay. In the writer, the buffer part is clear. I do have a buffer new, right? Don't I have a buffer new? I should have that. I need a new. One issue though, column position 0 is fine. What was the row? We are not touching the row at all right now. I'm only looking at the last row right now. That's fine to me. Okay. So this guy, I don't want to copy paste it. I don't understand. What are you trying to do? First we cast the integer this as a mutable raw pointer. Okay. But we did it as a buffer. Raw pointer to a buffer. Fine. So we cast it as that. That's the first part. Okay. Then we convert the mutable reference by dereferencing it through star. That makes sense. And again, borrow it again. Why are we doing this? It needs unsafe. Okay. Compiler can't guarantee that. Of course, compiler can't guarantee craziness like this. Why are we doing this though? Why isn't this enough? What does this do? Why not just use oh, what's the type of buffer? I got it. Buffer का type क्या है भाई? Where is writer defined? It's a static ref. Okay, got it. Alright, so the new thing here, I'm gonna have a pub-fn new still, which is gonna just return self, right? That's it. Sorry, what happened? Yeah, it's gonna be returning self. This is not necessary because we're doing the casting right there. The casting is enough. Alright. Can I have a writer new at least? Pub-fn new. Okay, so this is gonna be a writer, column position 0. I need the color code. Take column position as well. call code, call code. You can do that way. Color code, no sorry, column position view size and color code. Okay, so the first thing I'm going to do is just get those. Okay, and then the buffer, so I'm going to go buffer is gonna be, so we need a mutable reference first, right? So this whole thing is unsafe. Sorry. Okay, so I need a mutable reference to something, right? So first of all, I have the XB OX8000, XB8000. What is the thing? OXB8000. So first of all, I have OXB8000. Leave it at that. Okay. It found I32. It expected the mutable reference to buffer, right? So I first of all cast this as a mutable reference to buffer. That's the first thing I do. Okay. Show me the guy, dude. Column position could not find in the scope apparently. It's right here. What's the problem? A field by that name exists in cells. I don't know why column position was crying, but okay, whatever. Fine. Okay. Yeah, show me the error. Not the syntax error, dude. Expected unit found I32 apparently. Line 7, that's the one. This is what I want. So I found a raw pointer and a mutable reference to it, right? So the first thing I'm going to do is this whole thing will be immediately dereferenced. So it's going to be a mutable reference to a dereferenced raw pointer. Where did the dash come from? It's as. Why does it jump around like that? Good. Alright, perfect. So I have this stuff now. Now let's go to main rs. I'm gonna remove this guy. Alright. I'm gonna say writer equal to writer. You're not public. You are public. Writer is not public. Writer new. Color column is 0 and color code let's create right here. So color code new has the thing. What does this take? Front and back basically, right? It's gonna be a color dot color, I don't know, red, and color light blue, cyan, light red, and light green. Okay, and this is gonna be green. Syntax error. Alright, so I have the writer, and then I can just do writer dot print, dude. This guy is print. Printf. Print. We're not formatting. This is print. Alright. And it's writer dot print Hey, welcome. Okay, this guy has to be mutable, of course. I don't need that thing anymore. Whoa, are you kidding me? I get rid of this. Let's see, dude. It compiles. Let's create the boot image. I love Suno, dude. The music is just amazing. Alright. Let's do this. It's hey welcome on top only. Why is it on top? Nope. RM, RF, target x86 thingy. Create it again. Wait, was the color right? I didn't see. What happened? No such file directory. Why is that changed? Oh, because it's released this time. Oh, this was a different binary. Okay. Did I do release? Oh, that's why the path is different. I have a hello. Oh, that's what the background color means. Okay. Let's change the foreground color to red or maybe blue. I don't see it as blue. Hey, it's not Python, dude. You have to compile the whole fucking ISO. Not ISO, but you know what I mean. Alright, our hello should now be. Okay, the foreground color is okay, one second. Sorry. The foreground color is wait. What is new? Foreground. Wait, what am I getting right now? I'm getting the foreground. Yeah, foreground is green and background is blue, right? That's fine. Isn't that what I'm passing? Foreground is yeah. No. Okay. Foreground, background. Blue and green. It's the opposite. Why is it the opposite? Let's see. So I think this is supposed to be. Let's see if that. I mean, that will probably solve the thing. Yeah. What was it in the example? The previous one? Not previous one. VGA text only. The initial colors, color code. Yeah, it's background and foreground. What did I put? Yeah, okay, I done it other way around. Dude, we have colors here. I don't know. How do I make this guy bigger? I don't know, dude. I don't know. Maybe just a command plus work? No. Oh, it captured my shift option, control option. Alright. It's a VM, dude. I can literally make a bootable USB with this and boot. Alright, and that's it with this VGA. Alright. Huh? We are doing formatting as well. We're gonna create a macro. We're not done. How far is it? Dude, it's 1 hour. It's already 1 hour. I have to stop.